In this problem, we're told to find the magnitude of the gravitational force between a planet with mass 7.5 times 10 to the 24 kilograms and its moon, with mass 2.7 times 10 to the 22 kilograms. If the average distance between their centers is 2.8 times 10 to the 8 meters, B, what is the acceleration of the moon towards the planet, and C, what is the acceleration of the planet towards the moon? Right, so we're going to be solving for three different things here, but first let's just understand what's going on. Right, so we have these two planets. This is the mass of our planet, right? So this is planet, and then this is the moon. And we're also told the distance between the two, and what we're going to do is call that a radius, because essentially we can imagine the moon's rotating around, so you can imagine the distance between the two is the radius. Right, so we have all this information here. 2.8 times 10 to the 8 is the radius, 7.5 times 10 to the 24 kilograms is the mass of the planet, and then its moon, right, is going to have 2.7 times 10 to the 22 kilograms. Right, and so how do we solve this problem? So I think the first thing we should do is just start with A, and I'll explain it as we go on. So for A, what we're trying to do is find the magnitude of the gravitational force, right? So we're trying to find gravitational force, right? And we call this F sub G. So F sub G, right? And then what we're going to do is we're going to use Newton's law of universal gravitation, which basically tells us F sub G, the gravitational force, right, between two planets is equal to G, which is a gravitational constant, multiplied by the mass of one of your objects, right? So we have two objects here. You could just write M1, M2, but in this case, we're doing the mass of the planet and the mass of the moon. So you just write mass of the planet times the mass of the moon in this case, right? It would just be your two objects, right, in general. And then you divide by the radius or the distance between their centers squared. So radius squared. So this is the formula we're going to use to solve, right? So G is called the gravitational constant, which is basically just a set number, and it's something you need to know or write down or memorize. And this is what it is. So it's 6.7 times 10 to the minus 11. Right, so this is going to be the gravitational constant. It's something you have to memorize, and we're just going to have to plug it in. Right, so we have all these information, or we have all this information. We have the mass of the planet, we have the mass of the moon, and we have the radius. Right, so all we have to do is just plug in the information if we want to solve for A. So what we got to do is just plug in. So G is 6.67 times 10 to the minus 11. The mass of the planet is 7.5 times 10 to the 24. Mass of the moon is 2.7 times 10 to the 22, and then we're dividing by the radius squared. So the radius is 2.8 times 10 to the 8, and then we're squaring it, right? So if you go ahead and do this, right, plug this in your calculator. If you do this, you're going to get F sub G, right? So this is going to be rounded too. So F sub G is going to be equal to about 1.72 times 10 to the 20. So 1.72 times 10 to the 20, and then we measure force in newtons, right? So all this cancels out and gives us newtons, right, because we're measuring force. So F sub G is 1.72 times 10 to the 20 newtons, or this is your answer to A. So this is A. Let's move on to B now. So now that we know the force, right, so what we want to do is find, for B, the acceleration of the moon towards the planet, and C, the acceleration of the planet towards the moon. So in order to solve this, what we're going to do is just use Newton's second law, right, which is F equals ma. So force equals mass times acceleration, right? Because if we take the gravitational force and we divide by the mass of whatever one we're choosing, right? So for B, we're trying to find the acceleration of the moon towards the planet, so we're going to use the mass of the moon for B, right? So it's really just going to be the F of G, right? Because this is the gravitational force, it's the sum of the force, right, is equal to the mass, right? In this case, we're doing the moon, so it's the mass of the moon, right? And we're solving for acceleration, so you divide by the mass of the moon. So really, the acceleration is just the force, or the gravitational force, divided by the mass of whatever object. So we can just go ahead and do that. So A is going to be equal to the force, right? So 1.72 times 10 to the 20 newtons, and then you're dividing by the mass of the moon, which is 2.7 times 10 to the 22 kilograms, right? So if you go ahead and do this, right? So 1.72 times 10 to the 20, and then divide by 2.7 times 10 to the 22, you're going to get 6. You're going to get 6.37 times 10, and then it's going to be to the minus, 10 to the minus 3. And then the units are going to be in meters per second squared, right? Because that's what we measure acceleration in. So 6.37 times 10 to the minus 3 meters per second squared, right? So that's B. Now let's do C. So C is the same thing, right? We just take the gravitational force, and then we're going to multiply by the mass. And this one is going to be the acceleration of the planet towards the moon. So the mass of the planet this time. So mass of the planet times the acceleration, divide by the mass of the planet. Acceleration is equal to the force of gravity, 1.72 times 10 to the 20. And then instead of dividing by the mass of the moon, like last time, we do the planet now. So 7.5 times 10 to the 24. Yeah. So just plug this in. So 1.7 times 10 to the 20 and then divide by 7.5 times 10 to the 24, you're going to get that A equals 2.29 times 10 to the minus 5, right? So these are all rounded, and then meters per second squared, right? That's what we measure acceleration in. So 2.29 times 10 to the minus 5, that's going to be the acceleration. Keep in mind what this is. This is the acceleration of the planet, so you can denote it a sub p, and then this was the moon. So this is your answer to A, right? So the force or the gravitational force. Your answer to B was this right here, 6.37 times 10 to the minus 3, and then this was your answer to C. But yeah, so these are your answers, and hopefully you found this useful.